In this question, you can see I've drawn some pictures here, and I'm considering the difference in bonding. This difference in bonding explains this difference in behavior as described. You can see this is a lattice, ionically bonded. It's a salt. This, on the other hand, H2S, is completely different. It's a molecule. It has covalent bonds. I could sketch H2S as something like this, which you've seen many times before, the idea that it has a shape, it's a molecule. Now we can start answering the question. Imagine taking the lattice and putting it into a beaker. These are three-dimensional, really, and I haven't drawn the pluses and minuses, but there it is, it's a lattice. If you say, could this atom here, could it ever leave the lattice? The answer is no, not possible. It's strongly bonded to its neighbors. There is no possible way this atom could leave the lattice. I'll remind you of the nature of a lattice using interactive physics. Here the bowling ball comes in, strikes the ionic lattice. You can see very little motion. These ions are not separating from each other. Now let's look at the other picture, H2S. H2S. There it is. There's another molecule, H2S. They're in random orientations. The molecule is non-polar. So, what would hold this H2S to its neighbor? There aren't any hydrogen bonds, so this idea of dot, 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 we can erase that. There's nothing to hold them together. So this H2S molecule will randomly bounce around until it leaves. This H2S molecule will randomly bounce around until it leaves. There is no significant force holding these molecules together. The covalent bonds will not break. What comes out of the beaker is not sulfur separated from hydrogen, but the whole molecule, H2S, bonded in this way. That's what goes in your nose, that's what you smell. So to summarize, this idea of what particles are we talking about? What is the fundamental particle for ZNS? It's this big clump, it's a lattice. There really isn't any way to talk about smaller parts of it. With H2S, it's this group, the molecule. And the molecule, being nonpolar, has no strong attractions to its neighbor, so they randomly will disperse throughout the room.